Hello markers and peers of ENVE311, Pollution Control and Cleaner Production. Our group have chosen the pesticide industry to perform a comprehensive literature review in regards to pollution prevention and waste management practices. I hope you enjoy our presentation. Simply put, the first step involves manufacture of the active ingredient in a chemical factory, and the second step, formulation, involves mixing the active ingredient with a carrier. On this slide, the process for manufacturing liquid pesticides is shown. In this process, waste arises from rinse water, cleaning solvents, discarded raw material containers, pesticide dusts, off-specification products, and evaporative losses from volatile organic compounds. On this slide, the process for manufacturing dry pesticides is shown. In this process, waste arises from rinse water, cleaning solvents, discarded raw material containers, and pesticide dusts. Pesticides consist of an active ingredient which kills the pest, combined with inert ingredients to facilitate spraying and coating of the target plant. The active ingredients are usually hydrocarbons, mostly derived from petroleum. Some pesticides require additional elements such as chlorine, oxygen, sulfur, phosphorus, nitrogen, and bromine. There are a variety of inert ingredients used in this industry, the substances depending on the type of pesticide. Liquid pesticides usually contain kerosene or another petroleum distillate, and emulsifiers to distribute the active ingredient throughout the solvent. Powder or dust pesticides usually contain vegetable matter or powdered minerals. Waste characterization. It is estimated that about 200 kilograms of waste is generated per metric ton of pesticide produced. When characterizing this waste, we have divided it into gas, liquid, and solid. The gas pollutants in the pesticide manufacture process are particulate matter and volatile organic compounds. The liquid effluents from pesticide manufacture result from equipment cleaning, by which toxic organics and pesticide residues pollute the water. Typical water quality characteristics of this wastewater include a chemical oxygen demand of about 13,000 milligrams per litre, oil and grease concentrations of about 800 milligrams per litre, and a total suspended solid concentration of about 2,800 milligrams per litre. Solid wastes can originate from contaminated discarded packaging, processed residues, and effluent treatment sludges. Solid wastes amounts depending on the process, and they can amount to about 3.3 grams per kilogram of product.
The minimisation of waste is extremely important and something that should be evaluated when choosing a waste management system. Waste can be minimised by choosing alternative treatments and also by the effective use of the pesticides. One waste minimisation opportunity for pesticides is the green or biological alternatives such as microbial pesticides and parasitic insects. This process is called biological control and uses things such as bacteria, fungi, and insects to combat pests. The use of biological control minimises the use of chemical pesticides. Biological control also has the potential to save money as well as lower the impact on the environment. Biological control is considered a specific strategy and in the introduced species only controls the population of the target species. This is in contrast to chemicals which can kill a range of species, some of which are undesirable. Biological control is also a self-sustaining system, meaning that once it is in place it can continue to run its course, meaning money can be saved due to not having to repeat the control process. There are, however, some downsides to the use of biological control. The initial cost for biological control is expensive due to extensive planning. Biological control is also a slow process and takes time to see a drop in population compared to chemicals which provide instant results. Biological control also does not completely eradicate the pests and only controls them. Pesticide waste can be minimized all the way from industry production to use by the average person. Industry pesticide waste can be minimized by maintenance to storage tanks to prevent leakages and also a regular audit system to analyze any opportunities there may be to reduce waste. There are three ways the pesticide industry can reduce waste. These are to change the raw materials, change the production process, and to change the product being produced. These methods can be expensive. Extensive research must be done into alternative pesticides to ensure waste is in fact reduced and to make sure the environmental effect is not too large. Another way to reduce the waste of pesticides is to recycle and recover. Methods to clean up spills, such as using sawdust or clay, or the evaporation of wastewater, are useful for minimizing waste. Recycling of pesticides can save money in the future as well as lessen the impact on the environment. A common sense approach can be taken when using pesticides to minimize the waste produced. The EPA has released guidelines for the responsible use of pesticides. In this document, they outline the ways people can use pesticides effectively to minimize harmful waste. The document says to always follow the label instructions, always consider the circumstances when applying pesticides, and only apply pesticides to the target area. The following of the label instructions ensures that a negative impact on the environment and health of others does not occur. By applying pesticides to only the target area and using pesticides in the intended manner, without exceeding the application rates, the waste generated can be minimized. This can also save money by not using the pesticides too quickly and having the need to purchase more.
As an alternative waste treatment method, bioaugmentation and activated carbon were considered and investigated in order to decide which is the most appropriate method to treat the pesticide waste. Whereas a brief explanation of each method is as follows. Bioaugmentation is basically the introduction of a certain bacterial organics in order to speed and increase the rate of degradation of a certain contaminant, in this case being pesticides. Whereas activated carbon is used to absorb the chemicals of a contaminant, thus deactivating it and minimizing or completely removing the effect these contaminants may have had on the environment and the ecosystem surrounding it. After further research and investigation, activated carbon is seen as the more efficient way to treat waste, and thus the following design of a treatment plant was reached.
Effluent is the treated wastewater that flows out after processing. Thus, using the method mentioned above, or a septic system, to initially treat the wastewater, two methods could easily be employed in most locations. These being reserves and absorbent trenches. Both of these methods use the same base concept, this being using the soil's natural drainage process to safely return the effluent back into the environment. However, environmental circumstances could also factor into these methods, such as in a hotter, drier climate. Evapotranspiration can also contribute to returning the effluent back into the environment. In addition, soaking wells and sand filters can also be employed to further the quality and rate at which the effluent is returned. The effluent can also be directed into an irrigation system for farm or native land.